Hello and welcome to the virtual IO-Link days. Today about the topic IO-Link in the battery production. My name is Eloise Heckler, I'm marketing manager at Balluff, and with me in the studio is Sebastian, our marketing manager for market segments, and Stephan, product cluster manager for the area networking. Before we start right away with the session, very important information for you. If you have any question, please look to your right side, and there you can find the question and answer area, and there you can send us your questions and we can answer them in this session. And now let's start with the session and have fun.
Thanks, Eloise, and also warm welcome from my side to all the attendees. And to start things off, I think we all agree that since the EV market is continuing to grow heavily in all regions of the world, it's of particular importance to find out how to make your machinery, your processes within battery production super efficient, super effective, and at the same time reduce costs wherever possible. And this is also because, well, of course, there's a higher demand for high-quality batteries, for increased throughput, and also for sustainability topics to be taken into consideration. And in the following 30 minutes, roughly, we will take a deep look, in particular, how IO-Link technology in automation, in battery manufacturing processes can be of benefit in order to be more efficient, more effective, and reduce costs. And first of all, let's take a quick look at basically the enablers for that smart and cost-efficient and cost-effective battery production processes, where a lot of different factors come into play, as you can see here on the slide. No matter if it's about quality assurance, quality control topics, ensuring the maximum product quality, all the way to how can I really have my sensors not just in the right place, but allow them to work in the most perfect manner, and how can I maybe also make use of the data they generate. How can I streamline all of my sensor data communication in the right way, all the way to the PLC, to your systems to make use of the data being generated. For instance, not just to monitor your machinery and the sensors, of course, but also to find out how can I conduct a sort of predictive maintenance. I think this is the main buzzword here. Also in order to optimize your OEE, in particular to minimize or even bring downtime to zero. And the last thing here mentioned, easy machinery retrofit, is of course also of importance, since usually the machines used in these processes should not only last for a couple of years, but maybe even for a decade or longer. And there it's really crucial to kind of stay state of the art by implementing maybe new software, but also from the hardware side, having the possibility to implement further sensors, further hardware, whatever it takes to further maximize your machine efficiency. And now, Stephan, I would ask you, so how does, generally speaking, IO-Link come into play in all of these factors?
Thank you very much, Sebastian. Yeah, hi to everybody. And question is, how can IO-Link benefit in all these topics? And in one of the first sessions, we learned already about IO-Link in general, and what is the technology behind that, what kind of components do I have, what kind of tools can I use to get the data. And when we are talking about increasing the OEE or the efficiency of production plants or applications, then it's a lot about data. It's not all about data, but a lot. And this is what we are talking about here also today, to use the high amount of additional data in the IO-Link technology to increase my efficiency of my application and my plants. You see that here in this automation pyramid, we see where IO-Link is located at the lowest level here, which is the machinery level. And already here in this area, we are going to increase a lot of additional data which can help to keep the application running and at the end increase the overall efficiency. So we also talked about in one of the last sessions that we had the ability to increase the number of information or the set of information in a sensor or in a device already years ago, but the question was always how to get these information out of the device and transport it to the position or to the PLC where it's needed, or maybe to a higher level. And this ability we have now with IO-Link. So here already in this area we are going to increase a lot of additional information, and we have the chance now to divide these information into the process data, for example, switching signals or measurement signals from my devices, which will go to the PLC for controlling the application. And we have the additional information, maybe a lot of condition monitoring information, like environmental situations, like vibration and temperature, humidity, and all these kind of things, but also the situation of the component itself, like signal quality or internal temperature and all these kind of things, which can help to get an overview about the global situation of my application and my production plant. And with IO-Link we can transport these additional information to another level, to the IT level, for example, which is connected here, to get intelligent planning, analysis, and also to support the machine learning. So that means that IO-Link cuts hardware costs, because we don't need additional components anymore to create these additional information. We can do it in the same sensor at the end. And this simplifies the wiring at the end. That is something we learned already in one of the first sessions we had. And we're getting advanced fault diagnostic as well, to make the application more transparent and to be able to react much faster on changes of my environmental situation in the application. We are able to reduce the number of IP addresses as well. At the end we can reduce the number of the field bus modules, because we can work with the IO-Link I/O modules to collect all these sensor data instead of using field bus modules. And then we don't need to have always an additional power supply on the module or a field bus cable on the module. It's all on the 3-wire sensor cable. This reduces the cost as well. We have the data-driven quality assurance in the battery production according to all these additional information, making the application more transparent. And a seamless sensor to cloud connectivity. That means, where do I need these additional information? And we have now a really smooth path to the IT world to transport all these additional information, like internal temperature or humidity information, temperature or vibration and all these kind of things, to the IT world. Real-time condition monitoring, this makes this possible to react, as I said, much faster on changes in my environment. And also a quick swap of IO-Link sensors and devices to minimize the downtime as well. If there is, if it's necessary to exchange a device because of damage or something like that, it's very easy. That's what we also learned in one of the first sessions, to exchange this device and use the parameter set, which is located somewhere in my application, and download it automatically. But what does that mean now in real applications? And this is something what Sebastian will show us.
Thanks, Stephan. So of course, we're talking about increasing OEE here. We're talking about how to reduce costs, but to give specific examples of that is, I think, the best story we can tell here. And we will do that by taking a look at some of the key application areas in battery production, which is, for instance, about material mixing, so the anode and cathode material being processed. It's about coating and drying processes, as well as calendering processes, all the way down to, let's say, the heart of battery production, the cell assembly part, the cell finishing part, for example, also cell aging, and then all the way down to module and pack assembly processes. So let's start things off by taking a look at an example in one of the very first steps of these production processes, which is in fact about, well, storing anode and cathode material, doing that material mixing task, and so on and so forth. And this is also already where, of course, a lot of different sensors are being used, no matter if it's to check the temperature, pressure, any kind of liquids in these kind of tanks being used here. But this is already where IO-Link as a technology can play a big beneficial role here in order to play a kind of facilitator role to bring all the sensor data being generated there in a streamlined way, for example, through the IO-Link master to the PLC. And not just the sensor data, not just the measurements, for example, taking place there, but for example also diagnosis data, status data of the sensor itself, and so on and so forth, which then in turn allows you to have a real-time condition monitoring in place in such machinery, and also is kind of the enabler for predictive maintenance and trying to minimize the chance of any errors occurring, minimizing downtime or bringing downtime to zero. And then already going over to coding and drying process. So another field where obviously a lot of different sensors are being applied, and where also IO-Link, how we call it, acts as a gateway for cost-effective monitoring of the machinery, for cost-effective material tracking and monitoring, for instance, combined with industrial RFID here. And as of course also safety always comes first. IO-Link also helps you to provide a better control over your machinery and your operations, minimizing the chance of potential hazards occurring, and so on and so forth. But of course, the most crucial benefit also here remains the economical aspect in terms of cost savings. Less wiring required, simplified wiring, simplified setup and installation makes it much faster and easier to set up the IO-Link sensors or the normal sensors and everything around IO-Link, which of course helps you to save resources. And now here, this is really a specific example of such an oven of a customer of ours, where, as you can see here, a lot of different sensors are being used, no matter if it's about a common ultrasonic or inductive sensors, but also things like temperature sensors, pressure sensors, or condition monitoring sensors. And this setup pretty much also showcases the main benefit of IO-Link. Less wiring required, less costs, and at the same time, you enable that whole cosmos of condition monitoring, predictive maintenance as well. And to dive a little bit deeper into that kind of machinery, of course, you also have a lot of exhaust fans in place, a lot of different fans and service doors and whatnot. And also here, I think it's really crucial to have a real-time condition monitoring in place. In this particular examples, we're doing that with something called CMTK, so condition monitoring toolkit, to allow you to keep track of all the different things I just mentioned in your machinery in real time. And then even before anything happens, be alerted that you maybe have to act and prevent any unplanned shutdowns. And the interesting thing also here is that something like this is easily installable as a kind of retrofit solution in existing machinery, since you don't need that kind of complex setup and a lot of wiring. You can just easily implement it. And usually that toolkit comes with a kind of base unit, already integrated software, and up to 4 IO-Link sensors, and of course the relevant connection options to the relevant IO-Link masters and hubs. And then I want to show you another quite interesting example, which is all about format changes. And of course the battery production process in general is super automated, but still there are several areas where it is only partly automated or manual format changes have to be conducted. And this is why, for example, when using magnetorestrictive position measurement to do some kind of adjustments, we combine that with digital position indicators combined with IO-Link instead of going the analog way. Also in this instance, simplifying cabling, wiring, and so on and so forth. And at the same time, also easily enabling things like implementing a smart light. So giving your employees real-time status information in a really simple yet insightful way on top of the machinery, as you can see here, that your employees also know if something is up, even if they're not in front of a screen. And how does that look like in reality? So a practical example here is how an EV maker is advancing pretty much their roller position adjustment with the help of IO-Link and also with the help of digital position indicators here. And as I mentioned before, IO-Link here pretty much eliminates the need for analog systems with all the cable runs and cards and so on. And so also already from the hardware side helps you to reduce costs, but also, as I said before, makes it much smoother and straightforward to implement something like that, even maybe as a retrofit solution, replacing a former analog solution. And yeah, as you can see here on the bottom of the slide, usually such a position indicator comes as a IP69K version as well, with Ecolab certified housing, etc., in order to be usable even in, for example, clean room environments or any other special environments. And now I think this one is also quite real-time example as well, when it is about the post-drying processes in electrode production, how to streamline the whole foil slurry compression. And as you can clearly see, also here, a lot of different sensors are usually not just usually used, but also mandatory to use in order to keep up product quality. No matter if it's inductive sensors to accurately detect any kind of aluminium or copper-based foils, hydraulic sensors, roll color detection sensors, or even diffuse sensors for foil detection in winders or even unwinders. And also here, IO-Link is pretty much a jack of all trades here, since it streamlines the whole cabling and all the sensor data collection to a PLC and to high-level systems to make something out of the data and enable condition monitoring. And here, another benefit I want to highlight, it's not about only streamlining cabling and reducing wiring, etc. It's also about the ability, since you're using IO-Link masters, for example, here, you can easily replace any of the sensors without needing to change anything in the rest of the setup. And this makes it much easier to, as I said, do this kind of replacement in a short amount of time. And then a little bit going forward in that whole process, another interesting application example I want to show you is all about notching processes and how it can be enhanced by IO-Link, but for example also by RFID. So usually in these kind of notching processes, high-speed machinery is used. There are a tool which in fact helps to do that notching, is roughly doing 1 million cycles before it needs to be resharpened. And it might sound like a lot, but in fact, because this is really a high-speed machine, you have to resharpen that notching tool every, let's say, 2 or 3 days. And this is why it's even more important to apply technology like IO-Link and also RFID to, first of all, not just ensure that the right tool is used for the right product variant, of course, that's quite clear, but also to ensure that because of the data flow you generate this way, you also ensure that you are well aware of any decreasing quality in the tool itself, maybe, in order to reduce the chance of any downtime happening, and even way up ahead know what's going on. And especially because such notching tools are usually only resharpened by specialized companies, and you really have to bring that chance of anything happening in this kind of process to zero, pretty much. And then again, just quickly highlighting that in the end, of course, IO-Link brings a lot of potential benefits when it's about condition monitoring and so on. That's quite clear. But the core question people have in mind, hey, isn't it more expensive than the normal solutions I have been using so far when you compare it with IO-Link and all that functionality? And how can I really save money? And in fact, mentioned that a couple of times now, of course, it's about reducing the amounts of wiring needed, having much more flexibility in place in your system, etc., etc. And then on top, of course, you have all the smart functions, no matter if it's smart lights, which I showed before, condition monitoring, predictive maintenance, etc. And this one, I think, when we then go to the next step of the production process, is also quite interesting and real life example, like all the others too, is about cell aging. So usually the cells are stored in so-called high temperature cabinets for, let's say, 2 or 3 weeks at a constant temperature. And here it's really crucial to have that constant temperature in place, and you ensure that by, for example, implementing PT sensors, so platinum-based ones that measure the resistance, so 100 or 1000 stands for 100 or 1000 ohm in this case, resistance. And don't get me wrong, they work quite well. That's why they're being applied in such use cases. But they are costly and complex to implement because of all the cabling, etc. And it's quite a hassle to bring all of the data they generate and make it really useful. And this is also why customer of ours make use of IO-Link in this case, simplifying that sensor data collection, allowing to easily send all the sensor data to the PLC via IO-Link master, and all while supporting the common protocols such as Profinet. And in the end, this turned out to be super cost effective as well, allowing to cut costs by roughly 20%, which is quite astonishing for sure. And then, well, after the cells are finished, after they are aged, let's also quickly talk about streamlining the whole module and pack assembly processes. Well, also again, IO-Link can really play a big positive role here. In the end, I think it's also mainly about how to streamline the operations here, how can I streamline my assembly processes, especially when conveyor belts come into play, when AGVs, AMRs come into play, and when all kinds of robots come into play. And for example, here you can really benefit from not just using IO-Link, but for example, IO-Link wireless and inductive couplers to make energy transmission much more, energy saving, only using the resources you really need, making it in a way that you really reduce the wear of any kind of sensors because nothing has to physically interact anymore. And then all the way down to ensuring that, for example, like you see here on the picture, that you can directly place the sensors you need directly on such a rotary table. And this allows for, well, hopefully wireless monitoring of all the tasks being conducted in there. And then I already mentioned it, IO-Link wireless. This is pretty much the next level of IO-Link technology. So IO-Link wireless, like the name would already suggest, takes the proven technology of IO-Link. That's quite clear. Has a master hub and bridge system in place, but really helps you furthermore to reduce cabling, or sometimes you don't need any cabling anymore. Eliminating installation complexities, also this way helping you to reduce costs. But the benefits here are mainly about you have a much more flexible configuration possibility. So no matter if you have to, well, continuously do any adjustments in your assembly processes, you can then do so much more easily. And I think the last bullet point here, I already mentioned that you can really benefit from all the advantages the normal IO-Link technology has. And then, since I already talked about conveyor belts, conveyor technology, just want to show here what we generally call decentralizing with the help of IO-Link. So as soon as there are different conveyor motors or electric stoppers coming into play in such conveyor belts, IO-Link can also show its strength here by being able to control several ones of these at the same time, but also operating them individually, in this way saving energy too. And all while this comes, of course, with the other benefits that were mentioned countless times already: easy installation, much easier readjustments, maintenance, etc. And then a last example I want to give you, which is all about laser welding, laser cutting, and things like that, and how to ensure precise positioning feedback, for example, of that laser being used there. In this instance, a magnetically encoded positioning system, where it's obviously quite crucial to have a perfect positioning in place. Otherwise, you would destroy your housings, your material. And IO-Link also is useful here because it doesn't only help to provide the sensor data itself and the positioning data, but for example also status information, diagnosis information, to make use of, for example, for condition monitoring. And then let's also quickly talk about specialized solution, special requirements in the battery industry, quite similar to the semiconductor industry, also the food and beverage industry, for instance. In some parts of the production process, you usually have the need for, well, clean room environments where you minimize the chance of any contamination happening to zero. This is also what our job is, to meet all of your industry demands in the end. And for example, we had specific requests that were exactly about wet and dry room coding environments, where our customers are increasingly asking for specialized components, for example, to eliminate contamination also from the sensor side. For instance, evading any material being used in the housing. And this is why we provide zinc, copper and brass-free, so metal-free IO-Link masters and hubs, but also, for example, durable stainless steel nuts for all the cabling being used, all while supporting the common protocols such as CC-Link, EtherCAT or Profinet. But now I showed you a lot of interesting application examples where IO-Link can really play out its strength. But Stephan, maybe asking you back to the stage again, maybe you can tell us a little bit more how about such an end-to-end IO-Link enabled portfolio can look like.
Thank you. Yes, very impressive, I think, to see where IO-Link can be used almost in the whole production process of this battery production. In every single step, we saw that IO-Link really makes sense and can help to reduce the cost in all these different applications, and can help to increase the efficiency as well, either with reducing the installation cost always, right? Or on the other side, with providing additional information for diagnostic and condition monitoring. So this makes sense and can be used in all the different applications. But why can we cover this? Because we have in the meantime now a lot of different components in place. In one of the first sessions we talked about IO-Link in general and also about the IO-Link community, and we saw that we have in the meantime more than 420 different companies working in this IO-Link community, working on the technology and providing the components and the solutions. And that means in the meantime we have more than 23,000 different IO-Link components in the market. We have more than 35 million installed nodes now in the market, and that means we can cover almost every single application. Because of course we're talking about the sensor technology. Almost every sensor technology is in these days equipped with IO-Link technology. That means not only inductive sensors or capacitive or optical sensors, also ultrasonic, all the measurement sensors, they are coming with the IO-Link technology, as well as the master modules, the IO-Link master. That means the industrial networking, at the end the field bus modules. And we heard that we can cover all the different field bus networking systems in place. That means like Profinet and Ethernet IP and EtherCAT and CC-Link and all these kind of things. So a very, very comprehensive and complete portfolio what the whole IO-Link community can offer. Also included industrial RFID, so specific technologies for identifying the different tools, for example, or also the human-machine interfaces like a kind of smart light or signal light. All these different things are coming up with the IO-Link technology today. and machine vision and optical identification, like camera systems. Yeah, we have the ID code readers and all these kind of things now with IO-Link as well. But not only the components and the devices, also the accessory, of course, is important, like the power supplies, what we have, and the connectivity, like the cables, where the cables might be kind of easy because we heard that IO-Link is always based on the 3-wire sensor cable, or maybe the 5-wire sensor cable sometimes. But sometimes it might be necessary to come up with a specific cable material because of the environment where this cable is going to be used. So all this is available, also the accessories for, of course, for mounting the different components, and also the software how to configure an IO-Link system, how to set this up, how to parameterize the different components, what kind of software tools we have in place. We saw in our second session of this series here, and this makes it possible to combine all this also to system solutions. We heard one of them in the presentation here, which is called the CMTK Condition Monitoring Toolkit, and this is what we have done here to combine all the different functionalities and the IO-Link technology to one system solution in regards of condition monitoring, for example. So that means condition monitoring with streamlined data flow through IO-Link. IO-Link supports this condition monitoring with the additional information we can provide that eliminates the downtime by simplifying the troubleshooting. I get much more information in a much better time, and individually programmable and universally installable. That means independent of what kind of PLC system I'm using, what kind of field bus system I'm using, and that in the end simplifies and streamlines the data extraction as well. Some examples of these additional information here again, like we see the vibration detection, temperature monitoring, voltage and current monitoring, the signal speed monitor, and also the pin configuration. These are only some examples of additional features which are now available in the IO-Link devices. And we have also the humidity monitoring and the inclination and the logic functionality in the devices, and so on and so on. So a lot of functionality which really helps you to increase your efficiency and keep your application running. So that means let's jointly elevate your machinery and battery production processes with IO-Link. Yeah, we can offer the end-to-end sensor portfolio with enabling the IIoT connection. And we are supporting different technologies in IO-Link, like RFID, for example, and we are still setting the industry standards. Yeah, we heard that IO-Link already is in the market and is established, and we are working also on the future technologies. We heard one of them in the presentation, like IO-Link Wireless. This is going to be the next step, as well as safety, for example. And so we are continuing in the technology as well. So for today, thank you very much for joining us. And I think now it's time for the questions, right?
That's correct. Thank you very much to both of you, Sebastian, Stephan. And if you are wondering why Axel Hansen is not here with us, unfortunately he wasn't able to join us today, but in his place Sebastian Weik did a really great job in presenting you the various applications of the battery production. Now we start with the questions. What is the price range of the products with the additional data? So is it much more expensive or is it okay?
Okay. The price rate, of course, it depends on the component itself, but in general we can say that the IO-Link is not really a price increase anymore. In one of the first sessions we saw that IO-Link is already established. We have a lot of devices and nodes already in the market, and that gives us, or also the other providers, a chance to reduce the cost in this as well. There is a difference, yeah, because of the additional information and all these kind of things. But if you just think about one of the devices with additional features. If you only need one of these additional features inside, like vibration, for example, yeah, then you are already more cost effective than before, because you don't need an additional component anymore. You can use the same device, the same sensor you have to use anyhow, and get out these additional information, and that makes it much more cost effective.
Okay. What about the interchangeability of the devices? Is it possible to interchange different devices from different manufacturers?
Yeah, definitely this is possible. This is one of the first and basic requirements to IO-Link from the beginning when we started 10 or 15 years ago. That was the must requirement, that it has to be possible to exchange components also from one provider to the other, and we make this possible because everybody is doing his, or every provider is doing his components according to the specification. Yeah? And in this specification, we really fixed this, that every device has a specific basic set, what every device has to provide. And also we are working on the other side on the so-called profiles. That means the sensor profiles, to make it sure that also the process data will be in the same style, let me say, in the PLC, independent of from which vendor this device is coming.
Mm-hmm. Are there also safety solutions with IO-Link?
Yeah, safety solutions are available, especially from Balluff. We have since a long time safety solutions in our portfolio. This is a specific I/O module where you can connect safety solutions, safety devices like light curtains or interlock systems and so on. And the IO-Link community is also working on the IO-Link safety technology. This is one of the future things, and I think in the near time a lot of IO-Link safety solutions will come up to the market as well from different providers.
Mm-hmm. Now the question regarding aggressive chemicals. What about the use of our product in this environment? Is it possible to use it in the environment with aggressive chemicals?
Yeah, absolutely. I mean, just remember the very first specific example I gave before, which was basically about slurry mixing anode and cathode material steps in production, where, of course, either indirectly or directly, different kind of sensors have to come into contact with liquids, with any, well, potentially dangerous material, no matter if it's pressure sensors or fluid sensors, etc. So of course, also already there, it's essential to have everything well in place to last, built to last when being in direct contact with such material, that's for sure. And then also the other way around, of course, when it comes to IO-Link masters and hubs, which might not directly be thrown into dangerous material, that's quite clear. But this is also about an example I mentioned before about providing, for example, components that are free of any metals to prevent contamination of the production material itself.
Okay, great. Thank you very much. Now, if I didn't ask your question, then please stay in the chat. We can answer your question right away. We're now at the end of our session. And next week, we will have the session about robotic applications. So if you're interested in IO-Link in robotic applications, I welcome you to join us in this session as well. And if you're interested in the topic, how do I get the data with IO-Link, then I invite you to look up our previous sessions. We have one session about how do I get the data, and also some other really interesting sessions. So please look at them up, and you can also see the recordings afterwards. And now I really wish you a nice day and have a nice week.